Okay, so application of descriptive statistics. Descriptive statistics are widely used in various fields. Now, the use is not limited to these fields mentioned here, of course. For example, agriculture is not here, for example. Okay? Yeah, it's not limited to this. These are just a few examples. In business and finance, for example, in the banks, insurance companies, and all that. They are widely used in all, kinds of businesses, manufacturing companies, and all that. So they are used for analyzing sales data, customer preferences, and financial trends. In healthcare, hospitals, and other health services, they are used for summarizing patient data, monitoring disease trends, and evaluating the effectiveness of treatments. Okay. In education, descriptive statistics are used for assessing student performance, for test score distributions, and for learning outcomes. Of course, in social sciences, they are used for examining survey results and population studies. Okay. Now, I want to ask, I want someone to explain this. How can we use descriptive statistics for measuring, just speak on any of this, assessing student performance, test score distributions, or learning outcomes? Can someone share with us how can descriptive statistics be used for such? If you want to speak, just go ahead. Or pick from, yes. Okay, go ahead. Yeah.
For example, let's say test score distributions.
Okay.
We can use the histogram to like arrange their scores with the students. I don't know.
Yes. Yeah.
For
Go
example.
ahead. You are in order. Go ahead. Yeah. Yeah, that's
So
fine.
example histogram.
Thank you. Thank you. That's a good one. For example, take JAMB scores, for example. You know, there are many students, maybe over 1 million. I don't know how many students take JAMB. As many as they are, we can plot them, no matter how many they are. We can plot them with a histogram, and then at the end, the histogram will give you the shape of the distribution. That's what we call distribution. It will tell you it will show you if it's something that goes up and comes down like this, or if it is skewed, if it's bent to one side or something. Or are you getting me? So it gives you the shape of the distribution. Am I communicating?
Yes.
Yeah, to give you the shape. It will show you whether it's, yeah, that's a good one. Thank you. That's a very good one. Yeah, any other person want to share something with us? You can pick from any of these examples listed there. Just explain anyone, even if it's not under education.
Okay, SARS. From the assessing student performance, I don't know if you can hear me.
Yeah, we can hear you loud and clear.
Yes. Okay, so from the assessing student performance, you can use the bar charts to know
Okay.
the performances of the students.
Okay.
You can arrange maybe the student that got A's,
Yes.
then their scores and the rest, the performance. You can use bar charts to get those informations.
Thank you. Thank you. That's good. Now you see the two examples that we have been that have been explained now. You see, the first example talks about using histogram, okay, for score distribution. Score distribution. Because there are many different scores, okay? And histogram is used for numerical data, so that's very suitable. The second example talks about using bar charts. Now, when you are using bar charts, you cannot use score in that case, right? Why? Because if you use score, you have too many bars. The bars will be so many that the bar chart will be useless. Okay? Bar chart is not for such. Now, if you are using bar chart, then you have to use maybe like grade. Maybe A, number of people that get A will have their own bar. Number of people that got B, C. So in that case, maybe you just have like maybe just about like 6 different categories. That's why such is called categorical data. So because there are few, so the bars will not be very many. So it will be very easy to utilize the bar charts for analysis and planning. Then you can see the number, the percentage of number of people that got A, those that got B's and all that. Then of course, based on the standards, the policy of the school, then judgment can be made if the student performance is good enough or not. Okay. So if, for example, you have more of the student getting D, E, and F, and then the bar for A is very short, while the bar for E is long, is tall like Mount Everest. Okay, then it's an indication that there's something wrong somewhere. Okay, yeah, so those are very good examples. Thanks for that. Now, to wrap up, descriptive statistics provides essential tools for summarizing and understanding data. You see, for summarizing data and understanding data. Data is very important, but for the value to be gotten from data, such data must be properly summarized. Sometimes you have to be presented or visualized properly. Okay, and all that aid understanding, aids, our insight into that data, and the insights gotten from the summarized and visualized or presented data. Such insight can be used for making very useful decisions that will bring about improvement. The improvement could be something like improvement is in a performance, like performance of students in the school. It could be improvement in terms of profitability of a business. It could be improvement in terms of response to treatments at the hospital and all that. Okay. So by using measures of central tendency, dispersion, and visual representation, data analysts and researchers can gain meaningful insight before making data-driven decisions. Understanding this fundamental concept lay the foundation for more advanced statistical analysis, including inferential statistics. Okay, so this is a general overview of very general overview of descriptive statistics. Okay, the purpose of this class is to really, because when you mention descriptive statistics, sometimes a lot of people get confused about the difference between descriptive and inferential. Okay, they find it difficult to draw the line, the dividing line between them. So in this class, we have been able to establish that descriptive statistics focuses on summarizing and presenting data. Okay, and when you are summarizing data, there are a lot of things you do. Okay, after summarizing the data, then that will help to get your measures of central tendency. It will help to get your measures of dispersion. Okay, so sometimes we use these terms to also mean summarizing data. That's like part of summarizing of data. But in practical terms, to summarize data, there's a whole lot that needs to be done. For example, the data may need to be presented in a table. The data may need to be sorted. The data may need to be grouped. They need to group the data and all that. Those are some of the things we'll be looking at in this course. There may be need to, when you are summarizing, after summarizing, there may be need to filter the data, and those kind of things. Okay, those kind of things. So, and it's not limited to these. That's what I'm trying to say. But whatever you do, at the end of the day, as far as statistics is concerned, when you summarize, the end point, the end product is usually these things we have talked about. Those are the end products. Those are the things that the data analyst and decision maker look out for. Okay, that's what they look out for. For example, a manager may want to know, a good manager, he may want to know what is the average number of customers that walk into this a business for a transaction every week, or what is the average number of customers per day or per month. Okay, they want to know what's the average per month, for example. Okay, so you see that now brings us to mean, not just the total number, because now why will the manager be interested in the mean, the average? Because the number of people that come in each day, they are not the same. Okay, so today they might be 200, tomorrow they might be 50, the next day they might be 180, then on a certain day they may rise to 400. Okay, so which of these figures do we expect the manager to work with? So now it will be very important for him to know. Now, if I'm to use one figure to represent the number of customers or number of transactions, I have to be able to get one figure to represent that, and that will be the mean. Because sometimes the value is high, sometimes it's low. So the mean now, gives us a representation of the number of customers per day using just a particular figure, because you cannot use the high figure or the low figure. They are kind of random. Okay, something else the manager may want to know. The manager may want to know what is the maximum for each month. What is the minimum for a particular month? What's the maximum? What's the minimum? And what's the range? Okay, these statistics we are talking about, they are more important than we may think. They are extremely important. For instance, let me give you an instance of where maximum will be very important. Okay. Now, when you have an idea of the maximum, it can help you for capacity planning. Do you understand? For capacity planning. What if your facility cannot handle that maximum? What do you do? What if you have a maximum or the maximum rises to a point where your business facility is overstretched? That becomes a problem. Okay? So the business should be able to plan for either capacity enhancement or find a way to spread the customers or something. Okay, so these numbers, these figures, they are extremely important. They are used for planning. They are used for decision making. They are used for decision making. Let's say, for example, a management of a business discover that the business facility is now overstretched because the customers are too much to be handled. Now, they may try to investigate these customers. Where do majority of them come from? Is it from locations close to the business or from far away? Okay, let's assume that this business is situated somewhere in GRA. And then they suddenly discover, when they carry a little research, that a good number of the people, let's say like 1/4 or 1/3, come from Ugbowo axis. That will be an indication that citing another branch around Ugbowo will be a profitable move. Okay, I'm just giving you, examples of how some of these figures can be very important. Okay, yeah, of course, there's a lot more to doing business than just the statistics, because you can see right now, you as the analyst, you are furnishing the manager with top management with data, insight, and then management uses that insight to make decisions. Okay, so yeah, so that's that. And then that with descriptive statistics now, which is the foundation of analytics. Okay, so we are going to later on, we are also going to deal with inferential statistics, which is used mainly for prediction. Okay, you can't jump to inferential statistics without knowing descriptive statistics. You have to know descriptive statistics, because descriptive statistics is the foundation for inferential statistics. Is the foundation for inferential statistics. So let's not forget, I always emphasize this. It's not just knowing how to do the calculation is not enough. Knowing the purpose of the calculation and knowing the situations where the statistics are needed is very, very important. Okay. It's just like a workman that has different kinds of tools. Okay. When you are going to do your job, you put all those tools in your bag. Then when you get there, why do you have different tools? Because each tool is used for something unique, something different. So when a situation arises, you know which tool to pull out to take care of a particular problem. So as a workman, you must understand the nature of, the different kinds of problems you may face. Okay, should know the nature of those problems, and you should know the tools to be used for each type of problem. Okay, so that you don't end up using a hammer when you are supposed to be using a screwdriver. You understand? So the same thing here. That's why in analytics, we learn about data, all the different types, the nature of data. Sometimes when you are learning all that, sometimes it looks like a waste of time, but it's not, because that understanding is what will enable you to be able to utilize the tools you will learn, utilize those tools appropriately for solving problems. A typical example is what I told you in the course of this class, that different types of charts are used for different purposes. Yeah. So where you should be using pie chart or bar chart, you should, for example, bar chart, for example, hope you know that bar chart looks like histogram. Do you know that?
Yes, sir.
They look alike, but they are totally different in terms of their purpose. What they are used for is totally different. So if instead of using a histogram, you are using bar charts, you have missed it. Okay, you have missed it. So that will create a problem. So if instead of using scatter plots, you are using something else, there are some information scatter plot will give you that histogram cannot give you. Okay, so you should know when to use what, or line chart. Line chart is not listed here. Line chart is somehow like scatter plot, but line chart and scatter plot are not the same. They are not the same. Okay. When choosing the type of plot to use, it's not a question of beauty. It's not, oh, which one is more beautiful. I like to use this one. No, you should understand the situation, understand the type of data, understand the purpose, understand the nature of the problem, and then apply an appropriate tool for that problem. Okay, like I gave the example of line chart now. If you look at line charts and you look at scatter plots, they look alike. They look alike. But they are not the same. While the scatter plot is used to check the relationship between variables. For example, you are plotting something versus another, you are trying to see relationship between, like I said before, maybe the age of a child and the weight, something like that. But most times, line charts are mostly used for time series data, for time series type of data. Okay, where, let's say, for instance, you want to see the sales trends, in the first quarter of, rather, sales trend for the year 2023, and you want to compare that side by side with the sales trend for the year 2024. Now, in such a case, you are going to have two lines. So you can visually compare those two lines and see what they are like. Okay? That kind of problem requires a line chart, not a scatter plot. But visually, you see both of them may have lines, but there are two different kinds of problem. Okay? Now, all I have said now is not that I'm expecting you to understand everything I've said now 100%, because these are things we are going to talk about, deal with in details. Okay, but I'm just trying to lay a foundation so that as we move on, nothing will take you by surprise. Okay. All right, so that's for introduction to descriptive statistics. Suppose we still have a few minutes. Let's see if we can just do one or two other things before we call it a quit. Now, this is the Microsoft Excel screen. Okay, and in this course, the Excel screen you use matters a lot. Rather, the version of Excel that you use matters a lot. The Excel version that you use matters a lot. Okay? It's expected that you use Excel version
16.
Like 2016. Anything 2013, well, it's okay, but the best will be like not less than 2016. Okay, 2013 is okay. But to make things easier for you, let's just say 2016. Could be 2013 or 2016, but 2016 is highly recommended. Okay, because there are things there that, it makes things much easier for you. Okay. So this is the Microsoft Excel screen, like you have the various ribbon tabs up there. Okay. Microsoft Excel is a big package. There are so many things there. Okay, so what you learn depends on what you are using it for. If, for example, this is if this were a course for accountants, there are things we will kind of focus on. Being a course for analysts, there are things we focus on more because it's for analysts. Okay, so we are looking at using Excel as an analyst or for data analytics. Okay, so Excel is simple but very versatile. Okay, very, very versatile. Well, those are the tabs. Then if you look up here, you see, of course, this is the file menu. Okay, there are lots of things you could do through this. Of course, a lot you can do through the tabs. Each tab has its own various icons which represent various commands for various purposes. Okay, and then if you come down here, you see You see the formula bar, you see the name box. Okay, you see the formula bar here. You see the name box. Okay, if you click this, this F, you see there are various functions which you can, let's say you forget some functions. Let's say you forget some things. Let's assume you don't know how to compute average. You can just come here, click FX, you see the list here. Okay, so it's asking you to give the list of the items. So you highlight and just click OK. Okay, so it gives you the average. Okay, you see it has calculated it for you just by clicking here. So you don't have to memorize all the formulas, but it's faster when you know the formula. You just go ahead and do what you want to do. But you can also use the functions, insert function icon here. Of course, the formula bar is very, very important. This is where you type your, whatever you type, the formula appears there. Okay, so like here, if I say this is equal sum of everything here, you see that when I click on this formula, the formula that I use to realize this value appears there in the formula bar. This is why it's called formula bar, right? But if it's a typed word, it will typed value, it gives you the value. But if it's a calculated value, it gives you the formula that was used to realize that particular value. Okay, so down here you have the worksheet tabs. Okay, you can create more by clicking the plus sign. You can delete a worksheet by right-clicking and clicking delete. Okay, so of course you have the scroll bars, vertical scroll bar, horizontal scroll bar. Then you have the zoom bar here. So here you can zoom your Excel screen, can enlarge it, you can zoom it in and out, okay, and so on and so forth. Okay, and then of course down here you see the modes. Excel modes are shown here. Excel modes are shown here. Okay, so at each point you see the modes like this. This is ready mode now, which means it's idle. You can type whatever you want to do whatever you want. It's on enter mode when you start typing. Okay, but if after typing and then maybe you double click, it goes to edit mode, which means at this point you can edit the content of that cell. Okay, these are the worksheets. Sorry, column labels. Okay, there are various columns. These are column labels. Okay, you can see my own columns here ends at XFD. Of course, these are row numbers, row labels, row numbers. My last row is 1,048,576. These are cells. These are cells. These boxes are cells. These boxes are cells. This is the autofill icon. So assuming I type January, yeah, this is the autofill icon. I type Monday, for example. But if I type a figure to repeat it, if I type John, to repeat it, if I type a formula, let's say, for instance, I want to for instance, I want to square these items. I can type a formula equals this to the power of 2. Okay. You can copy that so it squares all of them and so on. Okay. Yeah, so there's a whole lot we can do here, but this is just a general overview of the screen. Okay, so we'll do more, we'll do some work here. But we're going to start Python early so that, because that's a long journey. But we'll spend some time also